All right, as Josh said, my name is Michael Moceri, and I'm the founder and CEO of MimoLabs. And we make AI agents and a lot of other stuff to make physical things. So just to kind of get a survey for the room, raise your hand if you've ever made something physical before. Raise your hand if you're an engineer, whether software or hardware. And raise your hand if you've never put a product to market, but you've always wanted to. That's been like a hardware thing. A few hands coming up. Pretty much everybody's got an idea. So with MimoLabs, what we're building is AI agents that can make physical things, whether it's a phone stand to an assembly for a vehicle to a drone. And what we're addressing is a problem where if you typically want to design something, the process kind of looks like this. Whether you're an engineer or if you're somebody starting new, you typically need to have a 3D CAD software which ranges from like $800 to over $8,000 a year. And sometimes if you're building something special, you need to have all of the engineering knowledge and experience to actually execute on that. And essentially, the more specialized you get, it's typical that the software just gets more and more expensive and way more out of reach for an engineer maybe earlier on in their journey of making something, or the individual who's just trying to build something and bring it to market. And then once you actually design something, you actually have to validate that it can actually be manufactured. And that's one of the biggest challenges in all of manufacturing and all of product design, is figuring out, can the thing that I just designed even be made, and can it scale to make other hundreds of units, thousands of units, or whatever that product may be. And at the end of it, you actually need the infrastructure. So after you validate that it can be made, do you even have the machines? Do you even have the capacity to make that thing? I think that's one of the biggest issues in American manufacturing, and in Detroit especially, is that there's sometimes a mismatch between design, industry, supply chains, and the expertise of the individual in order to build the thing that they're wanting to build, or what the need in the market is. So the solution to this is a suite of AI native tools and agents that are able to create, analyze, configure, and actually build the product that you're thinking of or designing. And what we've come up with is an agent framework and a platform that exists as a web platform, a command line interface for developers who are looking to build an application with this agent, similar to Claude, an API, software development kits, and integrations into your existing Claude or your ChatGPT platform. So you can talk to Mimo, and he can interact with whatever it is that you're looking to build and actually build it. And this is what the platform looks like, and I'll actually give you a demo of actually designing something. So go ahead and switch to demo mode. And we'll pray to the demo gods that everything goes well. All right, and we get here. So I'm going to pretend that I'm an industrial designer at a drone company, and my boss asked me for a new drone concept that he needs on his desk tomorrow. So I'm going to go ahead and just copy and paste one of the prompts that I have prepared here, and I'll read it out loud. The text is too small. And one of the best ways to get started with Mimo is just to talk to him. So I'm going to go ahead and paste the prompt here. And we'll go ahead and get that started. And what I said is, I need to make another stealth drone, this time with a 20-kilometer range, 5-kilogram weight, with a thermal camera at the front. Make sure it has a radar cross-section that can be minimized. Quadcopter chassis, generative design, lightweighting, no motors or rotors. I need this as a form prototype so I can print it overnight to show my boss tomorrow. So that's an absolutely ridiculous ask to ask any design engineer or just any human. It's just kind of like ridiculous.
Your boss, yes.
Yeah, exactly. So my boss, he's really strict, and he needs this now because he's pitching to investors tomorrow. So there's multiple different methods that we can generate a 3D model that can be manufactured. So what Mimo is asking me here is some basic questions, and is maybe just asking some suggestions. And for you hardware engineers out there, we can build with Mimo are the parametric models for meshes. And in this case, I'm going to generate a mesh, which is like the equivalent of asking ChatGPT to generate an image that you then would maybe sometimes need to take into Photoshop, separate into layers, and get all very detailed in a final product. And this is kind of the equivalent in the 3D space. If I just need some general concepts, then I'm going to refine over time. And imagine this again like Claude for software, where you're not just single shotting and hoping and praying that it creates your fitness app in one shot. You're actually going through and iterating with Mimo on this. And I'll actually zoom in a little bit. So raise your hand for concept 4, or raise your hand for concept 3. 4, raise your hand. Or concept 3, raise your hand. Concept 3? All right, let's see. So when you pick some of these concepts, and if you are familiar with other AI image generation tools like Midjourney, you can kind of iterate and you can edit the actual image that is the input for what Mimo then creates, the 3D model. So what Mimo is doing right now is generating multiple views of the model itself that we can then approve and then generate the 3D model from there, and then iterate, validate it, and everything else. So as he's doing this, there's a general concept called DFM in manufacturing. Whenever you need to make a physical thing, you're sending it to a manufacturer, there's always DFM. And that stands for Design for Manufacturing. So I'm going to go ahead and approve these different views. This looks pretty good. And then what Mimo is going to do is actually build the 3D model one voxel at a time. And Mimo has over 200 different individual tools customized specifically for him. Everything from the image generation to the validation of what he's actually designing and the 3D generation and so on. And the way that he builds this is one voxel at a time. So if anybody's familiar with Minecraft and how you build 3D models or worlds in there, it's one block at a time. So imagine that, but literally 1,500,033 times at the resolution that we're building at. And then smooths out the geometry, and then you get a dense 3D mesh, which is like all polygons and stuff like that. But we can work and iterate from there in order to create a manufacturable item. So while Mimo is generating this, I'll actually go into one of my stealth drone projects and show you kind of what a result looks like, and we'll monitor this progress on the right here in the chat window. So the web platform exists so that you can interact with Mimo as a pair engineer. So if you have an idea for a drone or for any other type of product, he can help manufacture that for you. So if I bring up some of the other concepts I've done earlier, a day ago, I can go ahead and analyze this 3D file that was generated with Mimo. And what you see here are all the different physics solvers and geometry solvers, which basically means that he's checking and verifying the file that can be manufactured. And then we'll actually highlight to you the changes that need to be made, and you can self-iterate on the model and verify that it can be manufactured with whatever process or material that I might have. So we can see the results are coming in here. Take a look at that. Now, raise your hand. Who's a hardware engineer or mechanical engineer in the room? Okay. How long would this take you to design in CAD?
In SolidWorks, probably easy for 3-4 hours.
3-4 hours?
I mean, if you want all that solid assembly design.
Yeah, exactly. So all of that time into a prototype mesh, and then I can tell Mimo to analyze this. And what Mimo will do is we'll take over the screen, and he basically autonomously controls the platform at this point. And you can see he's working using the different tools here, and he'll actually do a full analysis and actually understand the model itself. So if anybody's ever worked in 3D, or if anybody's just even looking at the models here, let me just do a quick.
Hey, while you're on that, like, do you support native exports to like Blender, Maya, Rhino, like all these different softwares? Like, you also said SolidWorks and AutoCAD, like, because this seems really cool and different than like the typical coding agent or whatnot.
Yeah.
But like to me, it's like if you can seamlessly integrate it with like these different softwares that are popular, like that's A1, man. Like that's sick.
And the answer is yes. And
okay.
any other CAD program that has an MCP server, which a lot of them do, but you can even just use Mimo on your desktop and control the other software. So essentially, Mimo is already compatible with most of the other softwares out there that allow you to connect with an API or something else. So you can see Mimo here. Mimo is trained essentially on my past 16 years in the industry. Where my past company, I started with a gentleman here in an NASA shirt. We had a 3D printing service company here, and we eventually spun out a software company that served over 10,000 businesses globally that were doing additive manufacturing, CNC, across companies like Peloton. We had US Naval Research, a bunch of universities that were using it, and other contract manufacturers globally. So a lot of the context and understanding that Mimo has about manufacturing is based on that experience, and being able to cross-reference and pattern match against the literal millions of objects that I've manufactured before in my So when you see Mimo running all these tools and analysis, this is outcomes-based engineering, where Mimo already knows predictably the outcome of what he's generating before it's generated itself, which is what any good engineer would know. When you tell any hardware engineer or software engineer, I need to build X, Y, or Z, they're going to be thinking in their mind, these are the failure modes, and this is what to watch out for, and this is how we're going to plan to build it. Mimo does the same thing, but in 3D CAD with the design for manufacturing principles applied to it.
Where can I sign up? This seems sick.
MimoLabs.ai.
Okay.
So, So all this stuff that he was doing on the right, he's basically self-validating the geometry that he created, similar to how in software you run your software tests and your checks. He's cross-validating all of the geometry and the features and identifying semantically and understanding what's on the 3D model itself, which means any CAD software from my hardware engineer friend here, does SolidWorks tell you what is an actual drone arm, or does it tell you more of like what's a hole? Like it doesn't understand anything. SolidWorks doesn't understand anything. Exactly. So Mimo understands the full model and the intent. So if you understand the intent, the model, the geometry, and the physics behind manufacturing, you can all of a sudden do what's here. If anybody, raise your hand if you've ever 3D printed something before. That's fucking awesome. 10 years ago, that would have been like one person, and it would have been me. So if anybody's 3D printed anything, you know how complicated 3D printing slicers are, right? So what we've built in the back end too is the world's first AI native slicer, or CAM software, that works both with 3D printing and with 3-axis CNC machining. So the geometry that I put in here, Mimo is picking all the material options and all of the different slicing options, which set how the internals are going to be built. It's called infill and support material, all that stuff. And it's actually simulating the build and generating what's called G-code, which is the language that the 3D printers or CNC machines understand. So by doing that, we're actually simulating the build, getting real-time materials for manufacturability, all the geometry solvers and the physics that go into the material, and then Mimo can output a price for you. So then you can tell Mimo, okay, iterate on this model so we get under $5 per unit for these drone bodies. And this is the cost for what it would be me to make, because Mimo referenced my machines and my materials. But if you don't have those machines and materials, or the capacity to manufacture at scale, we're partnering with a third party and other manufacturers across different processes so that you can order your parts with if you have a full bill of materials and the varied technologies and materials.
Are you paying yourself? Labor?
Yeah, no, so that's to basically, those are what your costs are.
There's the labor costs.
Yeah, no, the labor costs, of course, you gotta account for your time that it takes in order to manufacture something. So when you get onboarded with Mimo, he'll ask you, what's your daily rate, or what's your salary of the person who's actually running the machines, and we'll calculate the time that it'll actually take to take off the support material, reset the machine, and slice, and so on.
Hypothetically, you could just dog food this for yourself, right? Like on a bamboo or.
Oh yeah. Okay. So.
Okay, for sure. I see where you're thinking, man.
Yeah,
That's sick.
exactly.
Okay.
So when I save that config, it basically creates a digital inventory item. So I can download this file, load it up into Bamboo Studio or my favorite slicing software, and it's ready to go. I don't have to adjust any of those 256 different parameters. All it is just download the file, send it to the machine, no fucking around. So when you actually have to order something, you can actually order from a third-party supplier, and all the order tracking and everything is all set, so you do all that fancy stuff. But I also promised parametric models. So I showed off that drone, and what Mimo can do is, other than generating those 3D models that are mesh-based, so it's one single model, you actually can have individual components modeled, and all the way down to commodity parts that you need to buy, like the nuts and bolts from a third party, like MakerMaster or DigiKey or some other supplier. Mimo can import those geometries, whether it's a step file or whatever else, and encode that into Mimo's coding language in order to actually design these parts, and we can isolate these parts. And then Mimo can self-select and understands, again, if he understands your geometry and your application, he can self-select which parts need to be manufactured with what material, with what machine, and what supplier.
Yeah.
So, holy shit is right.
So what, when you replaced all these people's jobs, what are they gonna be up to, man? Cause, you just like, out of the people in the supply chain, you eliminated like 80% of them?
Well, let me ask, I mean, we'll get into the Q&A in a moment, but, you know, what I'll say is software engineering as a profession has only enhanced because of some of these tools.
I agree with that.
It's allowed the languages to be more accessible by other engineers who otherwise may have been stuck in a certain segment, but it also broadened the market, you know, horizontally in every direction. So from my perspective, in the interviews that we're doing with other engineers, is that I'm sure you want to get your hands on it, and same with you as well, just to go crazy and build the things that you've always wanted to build. So you're accelerating that work and allowing an entirely new class of person to be able to make products that they've always thought of. So my dream of all of this is not only do we want to accelerate the workflows of engineers around the world, we want to give the opportunity to the person who's had the idea scratching in the back of their head for a decade, who all of a sudden now has the capability to do so.
So can I ask you a question on that? So it's like, so for a software engineer, right? This to me is simple, because like I've been using this every day for the past 4 years. But how do you translate this to the layman? How do you translate this to the person who has that idea, who wants to build this, this type of drone or this type of technology? How do you kind of, simplify it to like make it easy that a 5-year-old could do it, or somebody who's just curious?
Exactly. So those are just different surfaces for Mimo. So if you keep it into the chat interface, it's the easiest interface of all time, and is obviously proven to be the fastest growing UX pattern in all times, other than words. So it's easy to use even for anybody who can just type a message and just chat with something, and being able to have Mimo give you the feedback to give you that. But the other thing I wanted to show real quick is fully articulated and simulated robotics in multi-part assemblies of over 100 different parts, individual parts.
Is this like the Figma prototype? Oh shit, everything moves. Everything articulates.
Yeah. And
that's ridiculous.
The way that we do this too is that we have multiple different physics solvers that we built in Rust. That was fun. And
dude, you really thought of everything. That's incredible.
not everything yet. There's still more. But this basically allows you to download each individual part. Mimo can export and identify again which supplier to buy these parts from or for you to manufacture. And that crashed my computer, nice.
I was curious, maybe I missed it, but how did you go from the 3D model that you're generating in the beginning to then the fully, like the assembly with all the parts?
Yes,
right?
you just prompt Mimo, and he'll even suggest after you get to the end of that visual design validation.
Right.
And then he'll suggest, okay, now we need to convert this into what's called a parametric model, into the assembly.
Okay.
So it's similar to, raise your hand if you've used Canva. So how awesome is Canva Layers? Does anybody use Canva Layers? Yeah. Is it good?
Hit or miss.
Hit or miss, yeah. So what it is you bring in a 2-dimensional image, and then you can break it out into layers like you would in Photoshop. And that's been kind of like the holy grail of like image editing for like the past 20 years. We're doing something similar, but we're actually like encoding it into like lossless geometry, which is like how Mimo codes all this stuff. So it's not a mesh, it's code that then can be converted into any format, whether it's a SolidWorks model with all the feature trees attached to it, or a mesh for 3D printing or what have you. There's more to Mimo. Happy to take more questions. Am I good on time, Josh?
Yeah, you're good.
Okay. I can show more demos, or answer any more questions, so happy to do it.
You focus on manufacturing. What about for people who are making apps that need 3D models?
Oh, exactly, yeah. So if you want to make
Oh, no way.
statues, so 3D models, here's just a bunch of examples, by the way. A lot of engineering examples for homes. The inputs for this were actually a photo just of a home elevation, like using like an actual architectural rendering, converting it into a model. phone stands, you know, if you're building a video game or if you're building something for Hollywood, you need a 3D asset. So right now that's just single color for sake of demo, but we can do full color in what's called physically based rendering, which gives all the color and lighting baked in. So you can download that just like that.
Is this just through the LM or is there a Gaussian splat or what?
Yeah, so we're not doing Gaussian splatting, so it's a diffusion-based method based off of, it's
3D group?
no, it's Trellis from Microsoft. So it's an open weights model, but Mimo is like a collection of multiple different models.
So you're just hitting that endpoint on the edge or circle?
That's local, so I mean it's fine-tuned. Yeah, so we're doing fine-tuning on all of our models. What you're seeing like on the chat mode here, this is the back end is Claude currently, but we're fine-tuning the Nemotron models, if you know about the other LLMs and stuff like that, on the individual outcomes-based manufacturing that we're training in. Because right now, if you're a software dev working in AI, we built a custom RAG kind of application. That's how Mimo is able to match stuff that's not in Claude's training in kind of what's proprietary to us.
Are you guys open source?
What's that?
Do you need help? Do you need like people to build this out for you? Like this is like the type of stuff, man. Like you're making like game change. Like this is Blender. This is GIMP. This is like open source shit that like people like builders will utilize, man. So like yeah, if this is open source, man, I'm happy to help where I can.
Yeah, so we're not open. We'll be open sourcing some stuff, not everything, but yeah, definitely happy to take your info and figure it.
For sure, man.
Are you able to choose, like when you download it, that's when you like to use Blender, when you download it, are you able to use, like, to choose the file that you want? Let's say I've created something, and I don't want it to finish it, I want to finish it myself.
Oh yeah, definitely.
Can I
Yeah.
do that?
Yeah, and I'm working to embed like actual like direct model editing inside of here, kind of like Blender style.
Mhm.
But you can already edit those parametric models by editing the parameters, or even just if you're savvy enough, you can go into the code and edit it. You know, yourself.
Okay, you have access to the code. Okay.
Yep.
Okay.
Yeah, so I work in robotics. The hand was interesting. And even for the drone, are you hooking up to a database of hardware to then match with the negative space that would exist within the robot or drone assembly?
Yeah, so a lot of that is actually physics driven. So knowing the constraints of what can fit into what, and
Yeah.
using like SDF based like differences between the space of in the tolerance of like a T-nut instead of an aluminum extrusion part.
Right, but like for the drone, for example,
Yeah.
you need a specific servo servo motor
Yeah.
and it needs to fit within that space. You can't just print it and like shove it,
No, exactly. So I mean, those are like reference files, right? But then you
Yeah.
would then go and buy from like a drone parts supplier. So those are stand-in assets.
What I'm
But
saying
there is
is-
a library of files that Mimo does reference for commodity-based parts. So like we have a whole library of like aluminum extrusion, motors, nuts, bolts, and stuff like that. So you don't have to like recreate something from scratch. But the things that are unique is not just the assembly; it's also parts of the geometry. Like for instance, let me bring up, for example, this one. Well, here you'll like this. You can even just throw in a schematic. So I threw in the schematic for a flight controller for the drone assembly, and it was able to do within just 3 prompts, self-correct itself like 5 different times, and was able to do all the traces, get the bill of materials for all the actual parts, find the suppliers, and get you everything that you need in order to start the prototype for that.
So for the hand that you showed, are those off-the-shelf motors that you've integrated with it, or is it?
Those were like NEMA 17 and NEMA 23 motors, so those were standard
Yeah.
commodity parts. So it knows, and I gave reference, I gave a manufacturing drawing for the NEMA 17s and 23s, and then it was able just to take the dimensions from that and then bake it in.
So the AI knows where to.
Yep. Yeah, and then gear ratios and stuff like that.
And for the fingers.
There was no reference for that.
Okay, so it's just raw.
Raw reasoning through
For an
the-
eye face solver or something like that.
through the custom constraint solver that we have, and it's also considering the constraint of the material and the machine that it'll actually be manufactured in. So knowing the tolerances between the spacing between the joints, where the actual servos go, and kind of like a basic layout. But you keep iteratively kind of building on top of it, the same way where if you tell Claude, build me the front end to this, now you got to hook it up to a back end, and then you have to iterate on top of that, dozens of times to build a spec for it. Where Mimo on the parametric side does best if you have a spec sheet, or if you have a detailed prompt for it. For the image-based and the mesh-based side of things, it's pretty more freeform and less constraint space.
Yeah, so off that, I see you're writing Vite. Like what framework? Like what's your infrastructure? Like, do you have a data lake? Are you what database are you using? Like, I'm just kind of curious about like what the infrastructure that you used to build this out was.
Yeah. So Vite. Check this out. So these are all the different traces and individual components.
Yeah.
And I'll bring up the conversation here so you can kind of see the.
Can you get this to like millimeter clearance or like?
Oh yeah, some millimeter. Is this the? Oh yeah, this is should
Not just PCB way.
Yeah, exactly. So this is the prompt I used. So I said, create a new parametric design for a flight controller for the quadcopter in this project. So it had to reference the geometry of the quadcopter because if I pull it up, it's going to take a while to re-render. But there's an example stack for the electronics in that assembly of that drone I showed. So it's referencing the clearance, the sizing, the mounting, and everything for that. And then it's actually reasoning and getting the context of not just the model, but of the different examples that we have loaded in as part of the custom RAG pipeline. And then he's capturing design views visually, but also self-corrects the code. And if there's any issues with it, he'll keep iteratively keep going. So you can see it's not perfect. Like there's some issues with this clip going over the hole here for the mounting. But keep iterating, and if you know what you're doing, it's very powerful. I'm not an electronics engineer. I'm very basic in my flight controller stuff, but for somebody who knows what they're doing, this would be powerful.
So I'm an electronics guy.
Oh,
I'll skip
sweet.
over that. I actually wanted to ask, where are you guys at business-wise?
Yeah, so we just announced Mimo not even like a month and a half ago, about a month and a week ago. I've been building this stealth mode for the better part of about a year, but haven't really gotten serious and taking all my proof of concepts and putting it into an actual workable product. That was essentially 6 months ago. So we've got about 80 people or different companies that are on our wait list, ranging from large OEMs to tier 1 suppliers to people who want to make things and starting a business. And we have a really good understanding of the problems that different engineers and individuals are looking to solve with something like this. And that's primarily to either accelerate the work they're already doing, and the other side of it, people who just need something to just be a participant in making something. So there's two camps. But we're fundraising right now. Got a lot of interest from local investors, those out of Chicago, a couple out of the Valley. So raising a pre-seed, and if anybody knows any other investors, shoot them my way.
Yeah, what's your cost for operating this? I'm noticing a lot of reflection. I'm expecting a lot of tokens are getting chewed up. Do
Yeah.
you have like an approximation?
Yeah.
Obviously you're running it local, but scaling this up and taking it to market.
How much did this meeting cost you?
What's that?
How much did this meeting cost you?
Yeah. So the answer is if you're using Opus is just really expensive. If anybody here is interested from the API side of things. So for instance, like doing this PCB design for 2 turns, this is about like $5.80. So I like to the
Oh, so it's using 1 million tokens per turn? Because isn't it 5 and 25?
No, for the output is $25 per
Okay.
million. Input I think is $5.
Okay, that's some
So-
heavy processing, man.
So, but it's iteratively. So like this was over, I think like you can see all the different turns. So every time that he's stopping and responding, that's a different turn. But he's continuing after he's done an analysis, and then we have basically a hook that says, take a look at the model, verify it, and then continue until it reaches a certain level of having enough errors that are solved, so then you can keep going on it. But to go further on that, any other AI company that is using a wrapper, whether it's ChatGPT or Claude, and from any investor standpoint too, the average gross margin in using just like a wrapper is like 57%, which is shit, in terms of running a business. So the goal for us, in order to optimize not just costs, but speed and everything else, is to run custom models locally, not in my like home server, but like locally as in our own inference stack, so that it dramatically speeds up test time compute and the thinking tokens across a model that has a larger context window at a much better break-even cost.
So it would be a server rack somewhere.
Yeah, and two, what makes Mimo so powerful is this, by the way. So we're not only relying on like AI compute for like AI models, it's actually the simulation compute. So the model takes the fusion of the data that it has context of, which is heavily dependent on the simulation of running the builds and all the checks on the actual model itself, the geometry. So a lot of the physics solvers that you might have in SolidWorks or something else running like either like CFD simulations is a big part of what we're building out as part of the core thing. So there's a compute stack that's heavily CPU bound, and there's another compute stack for the AI side that's very GPU bound. I want to give you more time to figure out
Yeah, I'm sorry, I'm gonna have to cut you there. But yeah, you can keep asking questions after.
But yeah, it's Mimo. Thank you.